I'm Anil Kumar, and this video is for my grade 10 IB student Melissa. I hope you also benefit from it. So we are sharing with you some questions from her assignment. The question here is, sketch the graph of f of x equals to 2 times x minus 1 square minus 3 and its inverse on the same axis. Second part of the question is, state the domain and range of the function that will also make inverse of the function. So that these are two parts to this question. I've already sketched the graph of f of x equals to 2 times x minus 1 whole square minus 2. It is a parabola with vertex at 1 and minus 3. But I'll discuss you how we sketched it, right? So let us first consider the sketching of the parabola. Parabola given to us is f of x equals to 2 times x minus 1 whole square minus 3. So whenever you sketch a parabola, what do you need? Especially when you are given it in the form of vertex. So we should find the vertex first thing. Vertex is at 1 minus 3, and the second thing is to find the steps. Since it is positive 2 times 1, 3, 5, 7. I hope you understand the concept of steps. Let me show you once here. So on the coordinate axis, we will locate the vertex, which is 1 minus 3, 1 and minus 3, so that is 1 minus 3. Once you locate the vertex, then follow the steps. 2 times 1 is the first step. So when you move 1 unit to the right, go 2 steps up, so you get this point. Then next step will be 6, 2 times 3. So when you move 1 unit more up, 1, 2, 3, 4, 5 and 1, 6. So you get the next step. So likewise, you can make steps and draw 1/2 of the parabola. Then you know this is axis of symmetry, which goes through the vertex. So the other points will lie on as a mirror image of the line axis of symmetry, which is x equals to 1 in this particular case, correct? So that is how you draw your parabola. Once you have drawn your parabola, to find the inverse or to sketch the inverse is a good idea to write some set of points. So let's write down the set of points which we have on this parabola. Beginning from the leftmost point which we have is at minus 1, 5. Then we have at, we can take this point which is 0, minus 1. And then the vertex itself, which is 1 minus 3. 2 minus 1 and 3 and 5. So these are the points on the parabola. To find the inverse, what we should do? We should just flip these points, right? So let's do it. So we'll find, let me use another ink. We'll flip and use that ink to sketch. So we have, let us say inverse is g of x. So for inverse, these points will just flip. So we get 5 minus 1, then here we get minus 1, 0, then we get minus 3, 1, then we get minus 1, 2, and then we get 5, 3. So these are some points which we are considering to sketch the parabola. We'll put these points and join them with the help of a smooth curve as it should be, right? Okay, let's begin by locating these points. So 5 minus 1, that means 5 units here and minus 1 gives us this point. Minus 1, 0, minus 1 and 0 is that point. And then we have minus 3, 1. So minus 3 and 1. So this is 1/2 of the parabola, right? Do you see that? So we flipped the left side of, we flipped one side of this, right? Left side of this. So this point got reflected that side. And you could do graphically also. How to do it graphically? Sketch a line y equals to x. Once you sketch a line y equals to x, then we have to find mirror image. So if you look at the vertex, then you have to move 1, 2 units to diagonally to the line. Move 2 units away, you get to the point of vertex. Here 1/2 unit, half unit. Do you see that? And here in this case 1.5 or not. Yeah, we are doing this part. So from this point we'll go 1 unit, 2 unit, 3 units. So the point is 1 unit, I mean, let's see it again. 1 unit, 2 units, 3 units. So 1 unit, 2 unit, 3 units. So this point is kind of wrong for us. Okay, let's see this. So we have 5 and minus 1. So it's good we checked it. 5 and minus 1 really is not this point. 5 and minus 1 is that point. Correct. So that is wrong. Okay. It's good we checked. You see how I got it? So if you see 1 diagonal, 2 diagonal, 3 diagonal, you are on the line. Then you have to go 1 diagonal, 2 diagonal, 3 diagonal. There is the point, right? So I wrote it correctly, 5 minus 1, but you know, we plotted it incorrectly. Anyway, one more important thing is, these are called invariant points. So wherever the graph crosses the y goes to x, those points are invariant. So when we join these points, we have to connect all these points with a smooth curve. So that is how we get 1/2 of the parabola, right? Now let's consider the other points. So we already have minus 3, 1. Now minus 1, 2. So at minus 1, the point is 2. Okay. And 5, 3. At 5, the point is 3. 1, 2, 3. Connecting these points and also the point which is invariant. These are invariant points. Okay. So we get this graph like this. So that is the graph of g of x, which is indeed f inverse, right? And is not a function. Therefore, I'm not writing x here. So that becomes the inverse. And I've shown you two methods. One, by flipping the coordinate points. Second, reflection on y equals to x. So the other method which we did was reflection on y equals to x for inverse, right? So these are the two methods which we should adopt. Now, second part of the question is state domain and range of the function that will also make inverse of the function, right? So we want to make inverse as a function. In that case, what? In that case, we should only consider one arm of the parabola. So let us consider the right side of the parabola. So that means we can restrict this domain to be greater than x equals to minus 1. So we now will do restrictions on function, which is f of x, so that the inverse is a function. At present, inverse is not a function since it fails vertical line test, correct? So now we can restrict as if I say domain of the function is restricted so that we have it x belongs to real numbers, but x is greater than or equal to plus 1. Okay, in that case we are restricting to only right side of parabola. Now this right side gets reflected on the upper half of this, right? So in that case, the function this which I have becomes inverse, a function itself. So in this case, domain is restricted and the range of the original function, however, remains the same, which is y belongs to, I should write y, belongs to real numbers, where y is greater than or equal to minus 3. Now let's look into the inverse function. What happens? Now inverse function, we are talking about g of x. Now for inverse function, domain is from minus 3 to the right. So the domain is x belongs to real numbers where x is greater than or equals to minus 3. As far as the range is concerned, range in this case is y belongs to real numbers where y is greater than the value of minus 1, right? Plus 1. So where y is greater than or equal to plus 1. You will find that the domain and range swap. Do you see that? So the domain of the function becomes range of the inverse function, and the range of the function becomes domain of the inverse of the function, correct? So that is kind of important to understand. What you could also do is, that is method 2, is you could restrict your domain to x less than or equals to 1. You could do that also. I'd like you to restrict the domain to x less than or equals to 1, right? That means this side. And then write down domain and range for function and its inverse. I hope that helps. Also what you can do is you can write equation of inverse function f inverse x in both the cases, correct? So restrict it to this part and then write equation of inverse of f of x in restricted domain. That should be a good exercise. I hope it provides you with learning experience and helps you to get all the things together. Thank you and all the best.